Next, we're going to look at compound inequalities. We're going to specifically look at and inequalities. So compound, basically, there's two parts to it. So there's two parts to inequalities. So first thing you want to do is you're going to solve each inequality separately. So I'm going to solve this separately. So I'm going to add 1. 3x is greater than negative 27 because you're down $28, but you get 1 back. So now you're down 27. Divide by 3, divide by 3. It's not what you're dividing to, it's what you divide by. So what I divided by is positive, so this doesn't flip. X is greater than negative 9. On the next one, 2x plus 7 is less than 19. I subtract 7, subtract 7. 2x is less than 12. Okay, divide by 2, divide by 2. X is less than 6. Okay, so now for my solution set for solving, my answer is going to be x is greater than negative 9 and x is less than 6. Okay, that's my solution set, solving part. Now what I've got to do is I've got to figure out how to graph it. And so here's how an and graph works, okay? Now, I will go ahead and teach it the way I teach it in Algebra 1. I'm going to have to do 3 graphs on top of each other, and I'm going to line them up. Okay, and I did not give myself enough room for this, so I apologize. And I'm going to kind of include these ranges values. I'll put 0 in the middle. This is going to be very white trashy of me. I'm going to put negative 9 way over here. And I'm going to put 6 over here because negative 9 comes before 0. 6 comes after 0. And I'm going to line these up. Okay. Just want y'all to get the visual of what's going on here. Okay. So let's start with x is greater than negative 9. So let's graph that. Well, it's going to be open because it does not have the equal to. Which way is greater than negative 9? Left or right? Right. These numbers to the right are greater than negative 9. Like 6 is greater than negative 9. 0 is greater than negative 9. 3 is greater than negative 9. Now, x less than 6. Open or close? That'll be open. And which way do I shade here? Which way is less than negative 6? It'd be left. Okay, because like all these numbers to the left are less than negative 6. All of them to the right are greater than. So you want to shade where it's true. Now, for an and graph, for your solution set, the solution set for an and graph is the region to where the shading overlaps from the top 2 graphs. So what region does the shading overlap? So when does it start overlapping? It starts overlapping here at negative 9, not including negative 9. When does it stop overlapping? It stops overlapping at 6. So what's happening here is from here to here, the shading is overlapping. And so for an and graph, you look for the overlap, okay? Because it's got to be true for this and this. Okay, and you can think about this in number terms. Think of a number that's bigger than negative 9, but less than 6. What about 3? Is 3 bigger than negative 9? Yes. Is 3 less than 6? Yes. So any number in this range that you pick would be a value that satisfies that inequality. And so that's my solution set.